Hey, welcome to Mathheadx. Today we're going to go over linear equations with two variables. Hey, welcome to Mathheadx. This is our part 2 video of tangent lines, slopes, point slope form, etc., etc., etc. Today we're going to be looking over how to just graph this and by inserting points. So there's multiple ways that we can approach this. First thing I like to do personally is put this in tangent line form. It's a personal thing. You can easily just start plugging in points and seeing what you like, but whichever works best for you. First, I feel like for practice, we're just going to put this in tangent line form, and then we're going to plug it in, and then we're going to graph it as we go. So, first thing I'm going to do is we're going to isolate this y. So what we're going to do for that is the same steps as prior. We're going to subtract 5x on both sides, which would give us negative 3y is equal to negative 5x plus 6. And then we're going to divide by negative 3, divide by negative 3, divide by negative 3. So these negative 3's cancel, and these negatives cancel, and this positive 6 over negative 3 becomes a negative 2. So we are now looking at y is equal to 5/3 x minus 2. Second thought, looking at this, maybe it would be easier to do it this way. We'll do it both. We'll do both. So I'm just going to erase all this to make space for everything. You know, wait, why am I doing it this way? Yeah, totally unedited, by the way. So, here's what we're going to do. We're going to put some initial points to plug in for the x value, and we're going to see what pops up for the y value, and we're going to place them across here, across this tangent line, and we're going to see what's going on. And so we're going to do the typical move of negative 2, we're going to plug in negative 2 for x, we're going to plug in negative 1, we're going to plug in 0 for x, we're going to plug in 1, positive 1, and positive 2. So, here's what we could do. We can either plug it in here or we can plug it into there. Both will work. Both of these two equations are equivalent. They're both saying the same exact thing. It's whatever you feel comfortable with doing, and we're just going to do it with both really fast. I'll do it with this one, and then I'll quickly go over this one. So we have negative 2. So for negative 2 for x, if we plug in negative 2 here, actually, let's just get rid of the graph. I'll redo this graph in a second. Let's just make space to find all these points, and then once we have all these points, we'll start filling them in. So we're going to have negative 2 here, so we have 5 multiplied by negative 2 minus 3y is equal to 6, which gives us negative 10 minus 3y is equal to 6. We add 10 on both sides. We have negative 3y is equal to 16. And we divide by 3. Or negative 3 rather. That is not a very satisfying number. Alright, so we have our solution now for this point. We have y is equal to negative 16 thirds. Alright, which is about 5 and about 5 1/3 of a point. So I'm just going to express that as negative 5 1/3. And now we could plug in negative 1. at -1, -1, which would give us -5 minus 3y, 6, right? And then we're just going to add 5. 5, add 5, -3y, these cancel, is equal to 11. I wish I picked an example that gave whole numbers, but it is what it is. It is what it is. Sad. Sad. Divide by -3. To isolate that y, I'll do it on both sides. And then we have those cancel, and we are left with y is equal to -11/3, which would give us 3 2/3. Yeah, 3 2/3, -3 2/3. So we have -3 2/3. And the reason why I'm doing that quick is I just see that this would give us 9 would be the closest thing out. 9 would, over -3 would give us -3, and our remainder is 2/3. So -3 2/3, or 3.666 repeating. Then we plug in 0, which is a lot easier. If you recall from our previous video, or we would do that for both of these, which we could still do that for both of these. We can find those intercepts absolutely. In fact, that's something that we will be doing, unless it shows itself here. So when x is equal to 0, we have -3y is equal to 6, which is a much more satisfying number. Divide by -3, divide by -3, and we are left with, canceling that, we are left with y is equal to 6 divided by -3 is -2. -2. Now, we have +1. +1 would give us 5 minus 3y is equal to 6. We subtract 5, we have -3y. Subtract 5 minus 5. 6 minus 5 is 1, equals to 1. And then we divide again by -3. Divide by -3. These cancel out, and we have y is equal to -1/3. So when x is equal to 1, y is equal to -1/3. And now we have 2. Last one. And then we can get to graphing. Woo. Oh, shut up, bitch. So then we have 10 minus 3y is equal to 6. We subtract now 10 on both sides. These cancel, and we are left with -3y is equal to 6 minus 10, which would be -4. And then we divide by -3 to isolate that y, do it on both sides. And note that a negative divided by a negative, or a negative multiplied by a negative, would cancel out the negative value, so these become positive. So we have a positive 4/3. Oh, and these -3's cancel out. So, positive 4/3. All right. Let's get to graphing. I completely forgot about just plugging me in here. One thing that would have been really easy is if I let x is equal to 3 and -3. Here's something that I could have done better. If instead of using 2, I could have used -3, -1, 0, 1, and 3. And if I plugged in the 3, the y is equal to. And this is why it's important to kind of understand this stuff, because if you just analyze which one would probably be easier, you can pick points that would, you can kind of get an idea and pick points that would make it so it's easier to find what you need to find for this. So we have y is equal to 5/3 x minus 2. Well, if I pick 3, if you recall prior, if we have 5 divided by 3 multiplied by 3, this would just give us 15/3, which would just give us 5. Every time the denominator would cancel out and the value of the numerator would be what remains. So if this was a 3, then our value is 5, and if this was a -3, it'd be -5. And then we're just left with y value is equal to plus or minus 5 for both of these. If I chose 3, minus 2. So it would either give us a positive, it would give us a +3 for here, and it would give us a -7 for here, which would have given us, so 3's would also have given us a whole value result. So why don't we just use 3 instead of 2? Because that would be much easier to graph. So we're going to use -3 and +3. We're going to use those. These are a little weird, if I might say. So this would be -7, and this would be a +3. All right. See, rewriting in tangent line form became a useful tool, because then you don't have to worry about like getting those exact points. So that way when you're looking at going up and down the slope, making sure that it's correct, it's a lot easier this way. It's a lot easier this way. So let's graph these points. So we have -3 for the x value, so we're going to go 1, 2, 3, -3. Y, x, and then we have -7, so we're going to go down 7. 1, 2, 3, 4, 5, 6, 7, and we have -7. So 3/3, or over -3 rather, down 7. Let's do this in blue. And then we have -1, -1, -3 and 2/3. So we have -3 here, and we have -4 here. So we just have to kind of guesstimate. Right, so that would be about right there. And then we have 1, 1, and -1/3. So -1/3, this would be like right here, roughly, very roughly. And then we have 3, 2, 3, and it would be a +3. Quite the jump. So we have 1, 2, 3, 3, 3. And now we can draw a nice straight, this should give us a nice straight tangent line. And this would be for the graph of y is equal to 5/3 x minus 2, or this original form. And that's how you do it. I know this isn't perfectly straight, but that's totally fine for this example. You can always just use a ruler that I'm too lazy to use. Yeah, so that's how you would solve this.